every time this camera is doing something to us. Do you think that I am lagging behind?
A bit, yeah.
I don't know why, because that's the same setup. Okay, hopefully not that serious. Okay. Today we want to talk about a very important lesson. So you remember we talked about quadratic equations mainly, and we learned the method of auxiliary variables, that sometimes you are given a polynomial equation which is not exactly quadratic equation, but if you can broaden your perspective, you can look at the same problem as a quadratic equation and then solve the problem. Now, another class of equations that we also might face during our studies in mathematics are the equations which we call them root equations, in which that we have a surd sign, yes, a radical sign, surd, S-U-R-D, okay? And we want to learn how we can solve these equations today, okay? So, might be the simplest possible surd equation or a root equation is just simply this. I would say square root of x is equal to 0. Yes? So this is the simplest possible root equation that you might face, yes? Square of a number is equal to 0. I'm supposed to find equal to 0. I'm supposed to find the value for x. The value or values for x. Of course, this problem is so simple that you really don't need, in principle, solve anything. It is clear that the answer to this is x equals to 0. Yes, because 0 is the only number, so that when you take the square root of, it becomes equal to 0. Yes? But in principle, if the problem is a little bit harder, how can I solve this problem? Okay. The general strategy is somehow to use legal mathematical steps, yes, so that I can get rid of a surd sign. If that's the case, then I am done, because I reduced my equation containing a surd sign to another equation which doesn't contain a surd sign, and hopefully I know how to solve that problem. But there is some delicate point going on here that I want to address. That when everything is finished, I will give you a little bit more exciting problems so that we can solve together, okay? So the general strategy, how can I get rid of this surd sign? Okay, so can you tell me how should I get rid of a surd sign?
Square it.
Yeah, exactly. I have this one. Then I would say that if it is supposed to be fulfilled, then I can square the left-hand side and square the right-hand side. Yes? And then what happens? This becomes x, and this becomes 0. And that is the answer that you were able to guess. But let me immediately tell you something. Let me recall your memory a little bit about. If I have a surd sign without any numbers here, this means that that number is 2. This number is a natural number, 1, 2, 3, 4, etc. For even ones, I need to be careful about the number that I put below that sign. I am not allowed to put a negative number. All the material that I am talking is in real numbers. Later, just a very small portion of this chapter is related to the complex number, and a more extensive discussion will be left for you in Math 4. Okay, so everything that I am talking is just in real numbers. Okay, and then here, I would say that I am not allowed to put a negative number below that. On the other hand, the output of any surd with even number here, the output is also non-negative. So it means that not only I have to provide a non-negative number below the square root sign, if I calculate the square root sign for that particular non-negative number, the output comes out is also non-negative. So this is why I always say, when I say square root of 4, it is just 2, not plus or minus 2. Okay? Okay, now assume that I ask you to solve this equation. What is your opinion about the value for x which satisfies this equation? The square root of x is equal to minus 1. Can you guess a number?
There is no such value.
Why? Because I just told you, yes? The output of a square root cannot be a negative number. So definitely everyone agrees that this simple third equation, root equation, doesn't have any solutions at all. But let me proceed this method. Let us see what happens. Okay? I want to follow exactly the same strategy. So what I do, I take this 1 to power 2, and I do minus 1 to power 2 as well. But if I ask you what is this, you would immediately answer x as before. But now if I ask you what is minus 1 to power 2, you would say this is 1. And you might mistakenly take this as the solution, which apparently is not correct. Because when we say that I have a solution, it means that it satisfies my original equation. So here, 0 was indeed a solution. You can check. Go back and replace x with 0. The left-hand side becomes a square root of 0, and a square root of 0 is indeed equal to 0. So this is perfect. But I take this one and put it back here. Use your calculator or your knowledge. You put 1 instead of this. You calculate square root of 1. It becomes 1. But the left-hand side is 1. The right-hand side is minus 1. Then this tells you that 1 is equal to minus 1. Nonsense, yes? Even though I am following the same apparently legal mathematical arguments, one of them gives the correct answer. One of them gives me a false root. Or sometimes we can call it fake root, yes? So this is not the answer. So in principle, how many solutions are there for this equation? Nothing at all. But my point is that the structure of these two equations were so simple that that was not a risk for us to get lost, yes? Because immediately we realize, okay, even we don't need to calculate anything. We know that there is no answers here. But mathematically, assume that the form of equation is so complicated that you cannot a priori see this misbehavior, yes? Then how should I know? Because apparently I am doing something legal in both of them. One of them give me the correct answer. One of them is not the correct answer. The structure was so simple that I immediately was able to detect this. But what happens if this equation is a little bit more involved? So it is not clear that how should I do that? Okay, so let us see what is the take-home lesson from this. The take-home lesson from this is that whenever you see an equation in which a third sign appears, this third sign might be square root, or might be the third root, I don't know, might be the fourth root, or etc., or a combination on all of them if the problem is more complicated. The main strategy to tackle these problems is one thing. You need to have it in mind. Get rid of all the third signs. Usually, if I want to get rid of a third sign, the first thing that comes to mind is raising to power. Yes? For example, if I have a cubic root, if I give you this equation, the third root of x is equal to 2. It is clear that here, To get rid of the third root, there is no point to raise it to power 2. Because if I raise to power 2, what will happen? This becomes the third root of this to power 2. On the right-hand side, it becomes 2 to power 2. But I cannot get rid of the third sign. Because this is power 2, this is the third root. At most, I can write the third root of x squared. Yes? And then on the right-hand side, I have 4, which is not good, because still I have the third sign. I need to look for x again. So when I have this problem, the most natural power to start with is not 2, is 3. Yes? If I raise both sides to power 3, then this power of 3 and this the third root, they will cancel each other, and then I will get x. And on the right-hand side, 2 to power 3 is 8. Is this a real answer? You need to be a little bit doubtful at this point, because you realize that this might happen, that I have a false root. Then I will take it back and put it in this equation. Does this really works? Yes, this is the third root of 8. The answer is 2, so this is acceptable. And that is the real root. Of course, I will talk about this. You don't need to be worried about odd numbers up there. The important thing is that when you have an even root, and when you start by getting rid of that even root by raising it to some power, it might happen that something jumps in, which is a false root. For cubic roots, fifth roots, seventh roots, this is more or less safe. I will talk about the source of this problem. Okay, so what I'm trying to say is that if you want to solve a root equation, the first step, someone might ask you, what do you mean by a root equation? A root equation is an equation, it is an equality containing a variable which includes a third sign. That is the meaning of a root equation. This third sign can be the second root, a third root, fourth root, a combination of these. That is called a root equation. The general strategy to solve this is to get rid of all the third signs. One potential candidate operation is to raise it to appropriate power so that that third sign is gone away. For example, if you are facing the third root, a good candidate is raising to power 3. If you have the second root, a good candidate is raising to power 2. If you are facing the fourth root, a good candidate is raising to power 4. Okay? So this is the general strategy. But then you need to think about something more. In the quadratic equations and any equations that we learned so far, there was no notion of a false root. When we found x, that was the end of the story. That was our solution. Sometimes, if you remember, I checked the solutions, but most of the time I didn't check because I could rely on those relations. But when I work with root equations, one thing that you need to remember is that when your root is an even root, you might get a root which is not a real root. That's a false root. It means that when you got your answer, the problem is still not finished. This is also part of the solution of the problem. So you need to take that x that you found and put it back there to see if it works. If it works, what does it mean if it works? If the left-hand side becomes equal to the right-hand side after plugging this number back. If that is the case, then you put a box over it and say that, yes, this is my real solution. But if not, that you need to write. That's part of the points that you will get in the exam, that yes, this is a false root. Okay, so this is the general strategy to tackle a root equation. And of course, root equations are usually much harder than the usual equations. Okay, and there are many technicalities going on, but the good news is that the problems that you are facing in the book are not hard at all. Okay, But I will probably, if you have time, I will try to solve a little bit more fun problems for you as well. Okay, let me go back and detect this source of error. You might say that, okay, come on, I am doing the same state as the legal thing. You're saying this is equal to this, I am raising it to power 2, but I am doing the same thing, I'm getting a false root. Okay, if you don't like, you can just be happy with this, but I want you to have a deeper understanding of what's going on. Can you tell me, before telling me something, do you think, what is your idea about why this is going on? Why the notion of false root might appear here?
I do not understand your question.
The question is that you see that in both cases, I am doing apparently legitimate mathematical steps. I am taking legitimate mathematical steps. How? You gave me an equality. You say that these two are equal, so I can immediately conclude if this is equal to this, the square of the left-hand side is also equal to the square root of the right-hand side. Is it logical or not? Yes or no?
It is logical.
It's logical. And then a square root of x to power 2 is equal to x. This is our knowledge. If this is not going to be the case, it means that all the mathematics structure is destroyed. So when we know, if I ask you a square root of x to the power of 2, what is it? Based on what you have learned so far, it is x. If I ask you, so instead of this expression, I put x. If I ask you what is this, 0 to power 2 means 0 times 0, it becomes 0. So it means that I got x equal to 0, which happens to be the correct answer. Because if I put it back, it works. But this equation is very similar to this equation. The only difference is that instead of 0, I put minus 1 here. I want to follow the same steps. I am looking for x so that this happens. So then it means that I do the same step. I square the left-hand side, I square the right-hand side, and then this one becomes x, this one becomes positive 1, x equal to 1. If I stop here and I think this is the answer, it turns out to be wrong. Because if I put it back, I will not again get the same answer. So because the square root of 1 is 1, but it is supposed to be minus 1. Yes? So I'm telling you why the same method, I am just following exactly the same method for these two equations. One of them gives the correct answer. One of them is giving the wrong answer. This is not a big deal for us because I told you that whenever you do this, you have to go back and check. If this is not working, you cross it over. But I want you to understand the origin of this error, the origin of this problem in front of us. Why do you think this is happening?
Maybe because it's a complex number.
No, because you see, no complex number is here.
Multiply a real number by just an even amount of times, it will always be positive. So if you do negative 1 times 1, it will be 1.
No. So what I'm saying is that no, might be I am actually expressing myself wrong. Because what I'm saying is that I am following legitimate steps. Why? Because so far, what is mathematics? Mathematics, it tells you that if you follow the rules exactly, there is no source of error. Okay, this is my question. I am following.
Well, there are exceptions to rules always.
No. So that's what I'm asking you. What part of this, what part is exception here? This is what I want you to understand. I am squaring, which seems legal mathematically, giving me two different scenarios, even two different answers. So you are right. It means that I am not following the exact rules for something here, but there are very few steps here. I'm just squaring, that's it. I'm just squaring. So is squaring legal or illegal? If it is legal, so why this mess? If this is illegal, so yes, it should be some very small thing to it that I am not respecting. This is what I want you to understand. It turns out to be a little bit deeper, yes. Deeper but very simple. Because let me go back to a very simple equation. So you see 2x plus 1 is equal to 5. This equation is given to me. Can you tell me if I want to solve this, what is the first step? What is the first step to solve this? Yes, I move 1 to the other side, which becomes what? 4. Do you agree? Do you agree? Okay. But now, so now that you are listening to me, you know that this was my problem. Okay? But assume that I am careless and before rushing out, I just clean, but I forget to clean this one. If someone comes into the room, they think that I am solving this equation because they don't see the original equation. Okay? So, but we know that this is a consequence of this equation. So you see that when you are following these steps, you are not in principle solving the original one. You are solving all the time, you are solving the new one. So you divide by 2, you get 2. Yes? If I ask you x is equal to 2, is the solution to this one or to that one? You would say that this is both a solution to this one and that one. But can you see the difference between these two equations? Of course, yes. This equation is not identical to this equation. Okay? But it is mathematically equivalent to that equation. What do I mean? Do you remember we had a little bit of this in math at 1C? We say that P implies Q, or Q implies P. If P then Q is not the same statement as if Q then P. So if a quadrilateral is a square, then the quadrilateral is a rectangle. That is true. But if the quadrilateral is a rectangle, there is no guarantee that the quadrilateral is a square. So if this one is taken for granted, I cannot immediately jump and conclude that the second one is also true. It might be true or might be false. If both of them are simultaneously true, then I would say that these two statements are mathematically equivalent. So if this is a hard statement, this is simpler than that, I can safely throw this away and just work with this simpler one because they are mathematically equivalent. This is what is happening here. From here to here, do you agree that I can conclude from, let me write it in a horizontal way so that you can see it. If I write 2x plus 1 is equal to 5, can I conclude that 2x is 4? The answer to this is yes. And if 2x is 4, can I conclude and answer that x is equal to 2? The answer is again yes. But let us check the reverse direction. If x is equal to 2, can I conclude back and conclude this? The answer is yes. Here, when I want to go from here to here, I divided both sides by 2. But can I go back from this to this? Yes. It is clear that I can multiply both sides by 2. So this arrow is reversible. It means that these two statements are not the same. You see, this is 2x equal to 4. Even a kid can realize the difference. This is x equal to 2. They are not identical, but they are equivalent. So it means that mathematically, there is no difference between this one and that one. Is working with this one easier than working this one? Yes, because this is compact 4, more compact 4. Okay? And then let us go from here to here. Can I go from here to here? The answer is again yes. Because if I add 1 to here and here simultaneously, then this becomes 2x plus 1, then it becomes 4 plus 1, which is 5. So this means that this one is equivalent to this one. This one is equivalent to this one. So this means that this statement that I started with is completely equivalent to this statement. But which one is simpler? Of course, this one. So I can just throw it away and look at this. So the operations involved, let us talk about the operations involved. I added -1 to both sides to go from here to here. And then I divided both sides from here to here. So I added -1, then I divided by 2. In the reverse operation, I multiplied by 2, and then I added 1. Okay? So these operations are reversible. But squaring both sides is not reversible. That is the source of error. Yes? Why? Because if I start from x is equal to the 4, I can raise both sides to power 2. Yes? This is what I am doing. I start from a statement, I raise both sides to power 2. This is completely legal. And then x squared is 16. Okay? But this arrow is reversible. Yes, because the other name of 16 is just 4 to power 2. But this cannot be done. Because if x squared is 4 squared, there is no guarantee that x is equal to 4 because x can be -4. So you see that these arrows were double-sided all the time. So it means that what you get at the end is equivalent to the statement that you started with. But here, what you get at the end is not equivalent to what you started with. So the source of this error is this. A squaring is not a reversible operation. Okay? So what you get after squaring is not exactly equivalent to what you started with. Here, what you get at the end is equivalent to what you started with. Okay? So this is why you don't need to check. The reason that we didn't check, because all these operations are reversible. But when it comes to squaring, this operation, so this tells you that if this is true, this is true. And if this is true, this is also true. But this is not my point. How should I know this is true in the first place? So going in this direction is based on the assumption of the truth of this statement, which I don't know in the first place, because I don't know x yet. How should I know that this is a true statement? This tells me that if this is a true statement, then x has to be 0. But there is no guarantee that this statement is true in the first place. So this is the source that you might get a wrong answer. Because this tells you that, okay, if this is true, then that x that you are looking for has to be equal to 1. But there is no guarantee that this can be true in the first place. This answer is based on an assumption. That assumption is that if this is true, then this number has to be 1. But it is clear that this does not work for 1, so it means that I don't need to look somewhere else. Because if this tells you, this calculation only tells you that if there is an x in this universe that satisfies this equation, that x has to be equal to 1. So there is no contradiction, but we see that 1 doesn't work. It means that, but by the way, this is also a solution. Why? Because potentially, if the equation is complicated, there might be any answer for it. How should I know about that? So this will help me know, don't look everywhere. Just look among these numbers, but be careful. These numbers might be fake ones. Why this is the case? Because squaring and in principle raising to even power is not reversible. Why I told you that you have to be careful for, you don't need to be careful for cubic roots, for fifth roots, because they are reversible. If I have x equal to 4, x equal to 2, let me make the number smaller, let me raise it to power 3. Then it becomes 2 to power 3. Yes? And then this means that x to power 3 is 8. But is this reversible? Yes. Instead of 8, I just wrote another name for 8, 2 to the 3. But is this also reversible? Yes. Because x to the 3 is 2 to the power 3, there is only one answer to it, and that x is equal to 2. So it means that these two are completely equivalent. So this is why, if I raise to power 3, if you want, you can check it, but there is no necessity behind that, because you are raising to power 3. Okay? These things are very important in mathematics, because this is why I'm explaining these things to you, because I want you to detect the source of what's going on. Okay? But if you don't like these kind of discussions, you can completely ignore these 10 minutes and then learn how to solve the equations, which is, of course, the main topic. The main topic is that a certain equation is given to you. You need to improve your skills by practicing how to get rid of the third sign, which could be quite complicated sometimes. Okay? I will practice about that. Okay, so any questions regarding these things? Hopefully you understood what's the difference. Let me just repeat this. This tells you that if this is going to be true, there is one possibility for that. There is no guarantee that this possibility works. But this tells you that if you want to look something for a solution, you don't need to look everywhere. There is only one point that might work, and that point is 1, and it turns out that is not working. So don't look anywhere else. There is no solutions. Okay? Because I am considering that this is true, and I got this. This tells you that if this is true, that x should be 1, not more than this. Okay. Now let me start. If you don't have any questions, I will start giving you examples of equations.
Give us example.
Yes, I will definitely. But any questions regarding this? Don't underestimate these things. If you want to go to a little bit, because even if you don't want to study mathematics in the future, now that you are studying, I would prefer to learn it in a very good way. Who knows? Might be someday you will need it. It actually, for biology, chemistry, Swedish, English, everything. When you are studying something, if you have time, learn it in a very good way. It might be you become interested in the future. And you will need it. At least you haven't wasted your time. Okay. So here, example. Solve the following root equations. Let me start with a simple one. So number 1, square root of 2x minus 3 is equal to 5. Okay, so these are at the level of the book right now. So we have enough time, yes. So here, the first thing I want you to understand, solve means finding x. Root equation, it means that you should expect seeing a root sign there. Okay, so I have equality, I have one unknown variable, and I have a third sign. So this means that this is a root equation. I want to solve this one. I told you that the general strategy is to get rid of all third signs. This part is technical part. For harder questions, getting rid of square root signs is hard. It's harder than the simple ones. But here it is completely trivial what to do. I want to get rid of this. I square both sides. If I square this one, let me write the steps. Even though if you are quick, you really don't need to follow all the steps. Okay, and I write them vertically so that I can ignore these arrows all the time. If you write it horizontally, you have to put these arrows, not equalities. Okay, then you know that this square root raised to power 2 is 2x minus 3. And then I know that 5 to power 2 is 25. You see again, if someone comes into the classroom, doesn't see this, if this has been erased, People think that we are in Grundskolan, yes, because they think that we are solving this problem. So I want you to understand, you are not solving this equation, actually. You are solving this equation. There is no guarantee that this equation is equivalent to this equation unless you check the final answer, if that's correct or not. But you know already how to solve that. I move 3 to the right, it becomes 28. I divide by 2, it becomes 14. Be careful. You are not allowed to put a box around that because it might be a fake root. Let me double check that. How should I check that? So the left-hand side is equal to square root of 2 times x. X is 14. This is what we found. Minus 3. And then I calculate this. You can use your calculator, of course. 2 times 24 is 28. And then I have minus 3. And then this becomes the square root of 25. But everyone knows that this is equal to 5. And that is equal to the right-hand side. So indeed, this is not a fake root. It is an acceptable root. And that is the only one. Before this step, what you can conclude is that if this is going to be true, don't look somewhere else. That number is 14. But there is no guarantee that 14 works unless you check it. We checked, it worked, everything fine, this is the solution. So you need to expect the same ideas over and over again with harder parts. The hard part is to get rid of the third sign. It was very simple because you had only one third sign in a very good way and then do it. Okay. Okay, let me now go to the next example. Number 2. I would write it like this. So let me write x so if you don't mind, let me not confuse you with these things first. Let me write here this word. So let me add here. I don't want to get confused here with 7. Let me just write it like this. Okay, one thing that is very important, I want to, again, this is an equation involving one variable, and I see a search sign. So that is the new topic today, root equation. And the general strategy is to get rid of square root signs. Okay, now can you tell me what is your suggestion? Of course, it is again clear that somehow I need to raise to power 2 to be able to get rid of that.
You need to square everything.
Okay, so this is the common mistake sometimes. You cannot square these things individually. Please write it somewhere in your notebook.
That's not what I meant. I meant like completely.
Exactly. If that is the mean, this is the only way. So let me tell you, the only thing that you can do, because you are telling me that if the whole expression here is supposed to be equal to 7, then it means that the whole expression to the power of 2 is equal to 7 to the power of 2. Okay. On the right-hand side, I really don't have any problems. It's 49. But now, can you help me? Because still, I am not successful. I see still a square root sign there. Now, what is your proposal? What is your suggestion? How to continue now?
Well, we can use squaring patterns, sort of.
Exactly. So you have to use a squaring pattern. There is no other way. I have emphasized a lot that if you have this, don't be tempted to write simply this. You can just write it over and over and cross it over. So this is not correct. The correct one is this one. Okay, so it means that now this is playing the role of my A here, and this is going to play the role of B. And then what happens? This becomes the first one to the 2 plus 2 times the first one times the second one plus the second one to the 2. Let us just write them in an organized way. This 1 to power 2, that's good for me. I got rid of surd sign. But 2 times x times this, it seems that I was not able to get rid of the surd sign. Plus x squared, even though this equation is very complicated, but forget about this, how do you say it in English? This complicatedness, I don't know, is that correct? Okay, forget about this, but it is not successful. Why? Because I started with an equation. By the way, this equation looks easier than this equation. But this is not, might be, this is correct, but the main point is that is still a square root is surviving here. Okay, so it means that raising power to power 2 naively is probably not a good strategy. Because you see that I was not only facing a more complicated equation than the original one, but of course, I still have the square root sign there. So I am making the problem harder for myself than making it simpler. So this is what I want you to learn. Before squaring it naively, just blindly, you need to think, might be, first you have to reorganize the terms and then square it, because it matters at the end. Okay, so I would say that this is an unsuccessful solution. This is strategically is correct. My strategy is to get rid of the square root signs. I need to square it. But technically, it was not helping because it becomes more complicated. Now, do you have any suggestions so that both I can follow my strategy, which is a squaring, and I will not face this problem?
Maybe you can move x to the other side.
Yeah, excellent. Thank you. This is the best way. So, if you want to do, don't be in a hurry. Whenever you see it, square it blindly. Most of the time, higher level problems need that you need to reorganize the terms in a way that with lower number of squaring, you can get rid of all the square root signs. Okay? So, and as Gustav mentioned here, the best thing to do is this. So this is what I am writing here is the solution. By looking at this problem, I move x to the right, it becomes 7 minus x. I just wanted to tell. So by the way, what I have done here is 100% mathematically sound and clear. Technically, there is a problem here that I don't want to continue because technically it becomes harder and harder. My goal is to make the problem simpler and simpler. So this is one thing that you need to learn. Even though I am doing everything right here, completely right, it doesn't give rise to the solution. So this is the trick in mathematics. Okay, so you need to find a way which not only is doable mathematically, but also makes sense, makes your problem simpler. Now, when you can just think moving it to the right and then square it, you will immediately see that you reach to your goal. But again, be careful. I am squaring both sides simultaneously. The whole expression on the left should be squared equals to whole expression on the right squared. But now, did I get rid of the square root sign immediately? Yes. The square root of x minus 1 to power 2 is just simply x minus 1. And what can I do on the right-hand side? I don't face any problem there. Why? Because this is just simple squaring pattern. So this is the first one to the 2. 2 times the first one to the times the second one is minus 14x. And the second one to the 2 is x squared. And then if you are doing your homework regularly, you can immediately be relieved at this point. Because this is not a big problem for you. You have trained yourself for quadratic equations. So you know how to deal with that. So this will bring you the relief. This is the way that you need to think in mathematics. Okay, so what I do, I see that this is a quadratic equation, so I move everything to the left. Yes, so let us do that. X minus 1 is there. I move 49 to the left. I move 40x to the left. It becomes positive, and this becomes negative. But I know that I need to write them in an organized, standard way. So minus x squared, I write it first. I have a 14x and an x here. I add them, it becomes 15x. This has to be written in the middle. And then I have minus 1 minus 49. It becomes minus 50 equals to 0. And then I need to start solving this quadratic equation. But this is a simple step for you if you have done your homework carefully. So what is the first thing that I do? I myself prefer this delta formula. So I would write it here. B squared is 15 to power 2, which is 225. So let me write, because there are 3 minus signs. I want to make sure that you understand what's going on. So 15 to power 2 minus 4 is minus 4, times A is minus 1, times C is minus 50. So be careful. So this becomes 225. How many minus signs are there? 1, 2, and 3. So the last one becomes negative. 4 times 1 is 4 times this is just 200. And the difference is simply 15. And 15 is positive. So I am expecting 2 roots. Again, 1 point. You see, I am not solving the original equation. If I clean this part and leave the classroom, the person comes in, thinks that we are talking about quadratic equations. They don't see that we are talking about surd equations, yes? So this is why I want you to understand, we are not actually solving the original problem. We are solving this problem. There is no guarantee, because this squaring is not reversible. There is no guarantee that the problem that I am solving is equivalent to the problem that I started with. So it means that I have to expect that might be there are some fake roots involved, because they might be the root of this, but not the root of that. Let us check. Okay, so if you remember, x is equal to minus b plus or minus square root of delta divided by 2a. So it becomes minus b minus 15 plus or minus the square root of delta divided by 2 times a. So this becomes minus 15 plus or minus 5 and then divided by minus 2. Then I have 2 options, yes? Either my root is, let us do it in our head, yes? Minus 15, positive 5 is negative 10. Negative 10 divided by negative 2 is positive 5. But don't put it in the box yet, because it might be that is a root, or false root is better. And then minus 15 minus 5 is minus 20, divided by minus 2 is positive 10. Okay? This is not the end of the story, because these are the solutions of this. If that was my problem, yes, this was the end of the story. But instead of solving this, I am solving this. I have to check. So let us check x equal to 5 first. I started from the left-hand side, the original equation, before changing anything, okay? So it becomes a square root of, instead of x, I put 5, so it becomes 5 minus 1 plus 5 is equal to. 5 minus 1 is 4. Square root of 4 plus 5. This becomes 2 plus 5. This becomes 7. And this is equal to the right-hand side. So I go back and put it in the box. It is acceptable for me. Yes? But let us check the other one. The left-hand side is equal to square root of, instead of x, I put 7 this time, minus 1. And then I will have plus 5. Oh, sorry, this is not 7. Sorry. This is 10. I don't know. This is 10. Okay, what is 10 minus 1? It is 9. Plus 5. 9 is 3. Plus 5 is 8. It's false root. It is not equal to the right-hand side. So you need to go back and write false root. These roots are not false roots for this one. And you see that before this, we are not solving. We are just manipulating the terms. The solution starts from here. So it means that in principle, we are solving this equation, not the original equation. And it turns out that this equation and that equation are not equivalent, because this has two solutions, this has only one solution. But I consider this a solution because potentially, how could I guess that these are the answers? Potentially, every real number might be an answer. So there are infinitely possibilities in front of me. I cannot check them one by one. But I reduce the number of possibilities to only two numbers. Checking two numbers is easy. I just check them and I realize that one of them is false, one of them is correct. I don't need to be worried about any other answers. So the only answer for this is 5. And then you can use GeoGebra to guarantee that. For example, you can move 7 to the left and draw this graph by GeoGebra. And then you see that this graph will intersect the x-axis at one single point, and that point is x equal to 5. So you see, this I would consider a very good example. First of all, it tells you that you need to be careful technically, even though you understand the problem completely. But if you do not respect to the techniques, you will fail. And then if you respect to the techniques, you can solve the problem, and then you see that we found two roots. Everything is in one problem, yes? So I was able to teach you how to think. This was a crucial step to move an square before blindly square. And then you see that when we solve, one answer is a fake root that is coming in, and we were able to detect that. And this is the end of the problem. So the problem ends actually here. All what you see on the board except this blue one should be, if this is an A-level question, for example, everything in black should be written as your answer to that question in the exam, even including these two. Okay? So especially in these questions, if you come to here, of course you get, if it has 3 points, up to here, you will get probably 2 points. But if you cannot recognize one of them is a false root, you definitely will lose one portion of that question. Okay, I hope that it was easy to understand what's going on. Yes, so this is the one thing that I want you to know, okay? So of course you can use a lot of tricks and techniques, but let me give you another example to see how it goes. Let me choose one. Of course, sometimes this is not included in the book. Might be we can talk about this a little bit later. But let me give you another example, which is a little bit more fun. So we want to solve this. A square root of 2 minus, again, another square root below it, and then I have 2 plus x equals to x. So let me call this one number 3. Okay? So I have a square root. Below this big square root, I have another square root. And then I want to make it equal to x, and I want to find that value of x. I think I was thinking that I just give you this lecture for one part, but the next lecture is on Friday, and it's a very short one. So I think we will practice on root equations on Friday. So I will not teach anything. On Friday, just bringing you examples to solve. Okay. Yes, let me just solve this one and finalize today's lesson. Okay, you help me. What do you think I should do? Again, this is a third equation because I am looking for x with equality. It's an equation. It contains at least one third sign, here 2, of course. So this means that this is a root equation. The general strategy is to get rid of all third signs. And then, of course, one candidate is raising to appropriate powers. But the previous example showed that it is crucial to organize might be and then a square or whatever. Okay, now I want to tell me just one step. If you want to solve this problem, what would be the first step that you will do?
If you square both sides first, at least you'll be rid of the first.
Yes, because we have to get rid of both of them. So if I can find a way to get rid of the first one, that is good. Why not? So the first thing, let me write them clearly. So I would write this to the power of 2, and then here to the power of 2. This is the first step. But this 2 cannot affect what is behind. So what I'm saying is that consider that this is a box. If I ask you square root of a box to power 2, then you immediately say that the answer is the box itself, whatever is inside the box. Inside the box, I have another third sign, so I have to write it in this way. Oops. 2 plus x. On the right-hand side, I have x squared. Okay, I consider this a step towards the success, yes, but it is not finalized yet because unfortunately I have another third sign. Tell me what to do now.
Move 2 to the right side.
Yes, we move 2 to the right side. So what happens? This becomes this, and then it becomes x squared minus 2. So you realize you took lesson, yes? Because you realize that if you want to raise it to power 2 like this, what will happen? Then this becomes a square. Of course, this becomes x4. Yeah, that's also a problem for us because higher degree equations are hard to solve, but that's inevitable. But if I want to square it, this becomes the first one to the 2. Good. 2 times the first one times the second one is the bad point, because then it will keep the square root sign for me. So if I want to square it in this way, it is not effective. So I square it. Before squaring, I move it to the right and then square it. Yes. Okay, but everyone knows what happens to this minus sign to power 2. It goes away, yes? So this one to power 2, the square root sign will also go away. So this becomes 2 plus x. On the right-hand side, what can I do?
Squaring pattern.
Yeah, squaring pattern. So the first one to the 2 is x to the 4. Unfortunately, that is a very bad example that I brought it up. Yes, because this is not at the level of your lesson. But anyway, let me see how can I fix it. 2 times the first one times the second one. I was suspicious a little bit about this. Okay, can you tell me why there is a downside to this?
outside to what?
To this equation. Why I'm a little bit regretting why I brought this example in, because this becomes a fourth degree equation. Yeah. And of course, some of the x4 equations you can solve, not all of them. Yes. If you don't mind, let me change this so that you can solve it. Okay. So let me put x squared here. It seems that I am making it harder, but not. So instead of x, let me start with x squared from the beginning. Nothing will change at all. This will happen. Do you agree? What I have done, I started with the wrong problem, I say. I start with x squared. Assume that this is the equation given to you. This is different. You cannot solve it. Okay. But then if I square it, so what I have done, I have replaced this x with x squared everywhere, assuming that I have started with x squared. But why this is possible to solve? This is the previous lesson. Do you remember? I, for example, take x squared to the left. Let us do it in our head. So I have x to the 4. I move it to the right. It becomes negative x squared. And negative 4x squared. It becomes negative 5x squared. And then I have 2 here. And then I move it to the left. It becomes positive 2. Yes? And then it becomes 0. Yes? Agree? Yes? But hopefully, if you have done your homework, you immediately realize you shouldn't be scared of this equation, even though this is a 4th degree equation, but you have enough experience. You remember the notion of auxiliary variable, yes? So I can use the notion of auxiliary variable. So this, you see that you need, this is mathematics. So you really need to know everything. But if you know everything, it comes automatically. It's not a hard problem, yes? So you reduce your problem to a problem without any third sign. Then what happens to you? The previous problem is hard, not at the level of your lesson. But if I change it to x squared, you get a 4th degree equation. But this is one of those types that you know how to do. At this stage, you would say let x squared be equal to t. Then x to the 4 becomes t squared. Then you plug it here. So it becomes t squared minus 5t plus 2 equals to 0. And there is a big problem here again. This is not a very good problem anyway. But let us solve it. Everything is doable, okay? So here I calculate delta. It becomes this 1 to the 2 minus 4 times this 1 times that 1, which is unfortunately 8. Why I say unfortunately? Because it becomes 17, and 17 is not a complete square. Whenever this number is not a complete square but positive, it means that I have to wait for working with bad numbers, yes? So delta is equal to 17, and that is positive, of course. Yes? Okay, and then t is equal to minus b, which is 5, plus and minus, this is unfortunate part, 17 divided by 2 times 1, which is 2. Yes? So this, I cannot do anything, and unfortunately, you have to keep it exact. So you cannot use your calculator to approximate. You have to deal with numbers of this form, in its exact form. Okay, but unfortunately, this is not yet finished because this is t. I am not looking for t, I am looking for x. Okay? So, what I do, I shouldn't have brought this problem, at least in this session. I hope that I am not confusing you. How much time we have left? Yes. So t is equal to that one. So I have 2 possibilities. Either t is this number. Yes. So I consider this. If t is this number, x squared is equal to that number. So this means that x squared is equal to 5 plus the square root of 7 divided by 2. Okay, then what is x? Don't be scared, by the way. If it was 4, I'm sure that you can solve it. You take a square root of 4 and put plus and minus. Instead of 4, you have a little bit complicated expression. So we put this square root on top of that. and then we need to put plus and minus. The bad thing is not up this, I would consider it a good problem up to this point for you. The point is that might be this is a fake root. It means that I need to take this back and put it into this equation, which is already complicated, to see if this one of them or both of them is a fake root or not. The hard part, I would say, is this one. Okay, but let us see how can we work around it a little bit. Okay, so then I have another one. Yeah. So leave this question if you don't like it at all. That was my mistake to bring it up. Okay, so what happens then? If I want to solve this, then x squared becomes 5 minus the square root of 7 divided by 2. Yes? Is this number positive or negative? Here you can approximate in your brain, yes, in your head. Square root of 17 is a little bit bigger than 4, but definitely smaller than 5. So this number is positive, so I don't need to be worried. I can take a square root. So it becomes square root of 5 minus square root of 17 divided by 2 plus and minus. So I wouldn't consider this problem a very hard problem if it was the final point. I've got 4 candidates, but you know that you have squared 2 times. It might happen that one of them, both of them, a number of them are fake ones. For example, I immediately realize without any calculations, that's also good. If you like mathematics, these are good things to learn. I don't need to check the negative ones. They are definitely fake ones. How do I know that?
Because you can have a negative square root.
No, negative sign is outside. If 5 minus the square root of 7, 5 plus the square root of 7 is definitely positive. 2 is positive. So this number below is positive. Square root of positive is completely acceptable. And then if that's unacceptable, I can put plus and minus outside. The reason is that if I want to see that if it's a fake root or not, I have to take this one and put it into the original equation. But I really don't need to bother to go through this method to calculate this. Because whatever here happens, it is supposed to be equal to x. But if x is negative, it is not possible for this square root sign to be negative. So you don't need to bother to calculate the left-hand side. It is complicated. But who cares? Whatever you get at the end for any x is a positive number. But if x is a negative number, it cannot be equal to x. So the negative signs are fake ones. Definitely. False. This negative sign is also false. But the bad point is about the positive ones. Okay, so the positive ones are bad actually. But positive ones are also fake ones or not. I don't know, you need to check. This is not easy. If I want to see if this positive one is the fake one or not, I have to put this number on the left-hand side and try to calculate to see if it is going to work. Okay? But how do you understand this is a fake one or not? Okay? So let me just have this for fun. Forget about this. Don't worry about the exam. This doesn't appear in the exam at all. Okay, so if I put this one here, what happens? Let me check. This becomes a square root of. This 2 is just this 2 minus the square root of this one. This square root that you see is this one. And then below that you have a 2. And then after that you have x to power 2. X to power 2 is this number. So this becomes 5 plus the square root of 17 divided by 2. Okay? And then what you need to do is have a rough approximation of this number. How much is that? This is 14 something, 4 something, plus 5 is below 10. It's 9 something, divided by 2 is 4 something, and then if you add it, it becomes 6 something. Yes? But the square root of 6 something is definitely bigger than 2. And then 2 minus a number bigger than 2 is negative, so that's also a false root. Yes? Because what happens below? This becomes negative, and this square root sign doesn't make sense. So we realize that this is also a false root. 3 of them are false roots, actually. And then our hope is only for this one. If I choose this one, then the difference would be this. But let me just approximate this. So it would be 9 minus 4 something, it's 4 something divided by 2 is 2 or 2 something. Yes? This is acceptable. Yes? If I do that, I need to check if this is equal to this number or not. Okay? I think that this is acceptable, because if you calculate this roughly, you see, if I add this is, if you put this number in your calculator, you get a rough approximation of that, and then 4, 9 minus this one divided by 2 is 2 point something, and that's acceptable. Yes. So this is the only solution that you have. Okay? So you see here, this was complicated. I'm sorry for that. This is, of course, a nice problem, but this is not at the level of your lesson, even though in principle it is. If you are interested in mathematics, why not? Which part you don't understand? You have all the knowledge of mathematics you need to understand this apparently complicated equation. Yes? I'm just following up to here. You actually told me what to do. And the only problem is that if you remember what I told you in the previous session, you got this. And then up to here, I think everything is normal. But unfortunately, checking the fake root needs a little bit more experience. If you have calculator in your hand, even checking the false root, which one is false, which one is not, is easy. You just put that number in your calculator and on the right hand side and check them if they are equal or not. Okay? And then if you want to check them using calculators, instead of checking that this one is equal to this one, because if your calculator only gives you decimal points, it is not easy to recognize them. I would recommend you to write this minus this in your calculator and to see if the answer is exactly 0. If the answer is exactly 0, it means that the number that you have found is exactly correct. Okay? So the only thing that I am not certain about, I have to recheck, but my hunch is that this is the real root, because first of all, this is positive on the right hand side, and when I calculated this approximately in my head, let me double check. 4, 9 minus 4 or something, yes, this is around 2 point something. When I take a square root of number a little bit bigger than 2, you see, this is smaller than 1. When I add it to 2, it becomes smaller than 3. And a square root of 3 is definitely smaller than 2. So 2 minus that one makes sense. The left-hand side is positive. So my hunch is that if you do it a little bit more carefully, you realize that only one answer is there. And by the way, this is a very successful process, because who could guess this number is the exact answer to this equation? So I want you to understand it was not possible. Even if you use GeoGebra, if you want to use GeoGebra, by the way, it is a very nice practice. If you have GeoGebra available, and if you are interested, just draw this graph. But you need to be careful to type it properly. If everything is according to prediction, you will see that there is only one intersection point with the x-axis. And then if you go to that point, of course, GeoGebra will not give you this exact value when you see. It gives you decimal place. So it means that you know something more than GeoGebra because you know the exact value, but GeoGebra only tells you the approximate value. Okay, I would say that that is a very good exercise. So you need to be a little. Right now I am very excited to have GeoGebra available to check it myself. So if you really like mathematics, you should also be excited to just investigate that one. Okay, sorry. If you are a little bit worried about this, you can totally forget about what I told you in this last exercise. You will not face even A-level problems. This I could call it, for example, A+++. Okay, so forget about that. They will not be. But I would say that the fun part of mathematics is dealing with hard problems. If you just want to follow very simple instructions, yeah, that's good for passing the courses, but not for learning and enjoying the subject. Okay, so yeah, we come and I will try to solve the problems myself first, not to give you this idea anymore. So I will give you more effective examples on Friday. Okay, and I will write on a SchoolSoft very late this evening because I have lessons over and over until 4 o'clock. When I reach home, it's a little bit late. So if you just check the SchoolSoft on the evening, you will see the instructions there. Sorry, I'm a little bit over time, so I immediately end this stream. I will be in Zoom for 1 minute if you have any questions. Otherwise,